Hi everyone! Welcome to the PVS-Studio channel. In this video, we'll take a quick tour of what our tool can do and how it can actually help you out during development. PVS-Studio is a static analyzer and SAS tool. In plain terms, it catches all sorts of issues in your source code, from simple typos to potential vulnerabilities and security flaws. Today, PVS-Studio Static Analyzer has 1,135 diagnostic rules, including 442 for C++, 206 for C# and 141 for Java. And that's not all! There are more than 300 specialized rules. For example, the C# analyzer has a bunch of diagnostic rules tailored for the Unity game engine. If you follow secure coding standards and use our tool, you are protected. PVS-Studio Static Analyzer supports many well-known software development standards. But which ones? For example, the analyzer supports standards like MISRA and AUTOSAR, which are designed to enhance security, portability, and reliability of software for embedded systems. As a SAS tool, PVS-Studio organizes its diagnostic rules based on OWASP Application Security Verification Standard, SI-CERT, and CWE, which is a big list of confirmed and potential software weaknesses. You might be thinking, cool, but do I actually need static analysis? In reality, using static analysis is a crucial step in development, especially when many people are involved and there's even more code to manage. Static analysis helps developers find various errors and typos while writing code, as well as reduce the back and forth between development and testing teams. Moreover, static analysis assists in searching for so-called zero-day vulnerabilities, preventing them from falling into the hands of attackers. Theory is great, but let's dive into some real-world examples. Here's one from the Microsoft All-ins project. Take a look at how the curly braces are placed here. The formatting clearly indicates that the else branch should be executed for the very first condition that checks if the variable is greater than 0. But here's the catch. Since there are no curly braces, the else branch will refer to the condition that is enclosed within the first if. PVS-Studio spotted this and gave the following warning. Next up, another warning worth looking at. Take a peek at the PVS-Studio warning. Here, the username value used to build the SQL command comes straight from an external source request.form. We're using this value without any prior validation, which is risky, because an attacker can sneak an SQL command like this, instead of the username, and gain access to all user data in the database. You might wonder, how does it catch all these issues? It's pretty simple. The analyzer first builds its own representation for our source code, called an abstract syntax tree. Then, it runs diagnostic rules on the tree using various analysis mechanisms to spot error in the code. So, what kind of mechanisms are we talking about? PVS-Studio relies on tried-and-true static analysis approaches. Alright, let's break down how PVS-Studio digs into your code. First, pattern-based analysis. It basically spots source code fragments that match well-known error code patterns. Then, symbolic execution that helps evaluate variable values that can lead to errors as well as check ranges of values. Next up, type inference. This gives the analyzer full info about all variables and expressions it encounters in the code. Data flow analysis evaluates the limitations imposed on the variable values when processing various language constructs. For example, using this mechanism, the analyzer can evaluate values that a variable can take inside if-else blocks. Taint analysis is effective for detecting uses of invalidated user input. For example, it can catch possible SQL injections in the source code. The analyzer also provides method annotation mechanism used to give more info about the used methods. For many popular libraries, we've created annotations ourselves, but you can freely write your own annotations in JSON format. And finally, intermodular analysis lets diagnostic rules to check functions declared in other translation units, making the analysis more thorough. We want PVS-Studio to be as convenient as possible for you. That's why the analyzer supports a bunch of popular development tools you probably already use. So, what kind of tools are we talking about? PVS-Studio has plugins for various IDEs like Visual Studio, IntelliJ IDEA, Rider, CLion, Visual Studio Code, and Qt Creator. It supports many build systems too: MS Build, CMake, Make, Ninja, Gradle, Maven, and any compilers that can generate the compile commands.json file. Plus, you can leverage PVS-Studio in a distributed build via Incredibuild. If you're into game development, PVS-Studio has integrations with Unity and Unreal Engine. You think that's all? No, we're just getting warmed up. Next up, you can use various tools for embedded development like Kyle, Microvision, DSMDK, IR Embedded Workbench, Platform IO, QNX Momentix, and TOM Go Generation. You'll say, we want an easy way to process analysis results. Well, PVS-Studio reports can be integrated with code quality tools like SonarQube, Defect Dojo, and Code Checker. To automate static analysis, you can freely run PVS-Studio in Jenkins and TeamCity, as well as in Circle CI, Travis CI, GitLab, Azure DevOps, and GitHub Actions. Wanna use virtualizations tools like Docker and WSL? PVS-Studio supports it too. And that's just a quick look at the tools compatible with PVS-Studio. Our analyzer includes built-in tools that can streamline your processes. Need to convert the analyzer report to another format, such as international serif format? Clock Converter comes to the rescue. Want to notify developers about issues in their code? Blame Notifier sends customized warning emails directly to the developers responsible for the code. Wanna try PVS-Studio? Get a trial version. Just follow the link in the description. If you want to dive deeper and learn how to use the tool, our detailed docs will guide you. The link's right below the video. See you later! Keep your code clean, folks!